And welcome back to Teacher Gimble's channel. Today we'll be going over Illustrative Math, Algebra 1, Unit 2, Lesson 6. If you like this video, please make sure to like and subscribe by hitting the button down here. Let's get started. Problem 1. Which equation is equivalent to 6x plus 9 is equal to 12? So I'm going to go through each of my answers to figure out how to do this type of question. So my x term has to be multiplied by 6. So if I want this guy to match, I'm going to have to multiply my first term by 6. But if I multiply one term by 6, I have to do it for all of the terms, which 9 times 6 is 54, 6 times 6 is 36. That does not create an equivalent expression, so I cut it out. Here, I need him to equal 6x also. So I'm going to multiply him by 3. But if I multiply him by 3, I multiply him by 3, and I also have to multiply him by 3. We get matching expressions, so we are good to go. 3x. We already know he needs to be 6. We got to multiply him by 2, which gets us 6x. If we multiply him by 2, we multiply him by 2, we multiply him by 2. These guys don't match. No go. This last one, well, our 6x matches, but we have a 12 here and we have a 9 here. So let's put this 12 on the other side. So we're going to subtract him from both sides. And we're going to get 6x minus 12 is equal to 9 minus 12. And then we want to get the 9 on the other side. So I'm going to add the 9. And now our 6x plus 9 is equal to negative 12. Well, this looks similar, but this guy over here is negative, which tells me he's a no-go as well. All right, so it's really important here to know the rules of what you can do to your expressions. So in this case, if you multiply one term, you have to multiply the rest of the terms, and you still get an equivalent expression. If you subtract a number from one side, then you subtract it from the other side as well, and you get equivalent expressions. But if you're not familiar how to do that, I would review these rules before going on to the next question. Problem 2. Select all the equations that have the same solution as to the equation above. So step number 1, I'm going to solve the equation above so I know what the correct answer is. I want to isolate the x. So first, I'm going to add and subtract. So when you are solving for an equation, you kind of almost always do PEMDAS, which is our order of operations, PEMDAS, but we're going to do it backwards. So first, I'm going to add and subtract everything that I have. So we added, subtracted that. Well, we added, it got to 0. We add to this side, we get to 36. And then going backwards, the next thing I need to do is I need to divide. X is equal to 12. So that is the answer that I want my other x's to be equal to. So now let's go ahead and solve. In this case, I'm going to get rid of my addition and subtraction first. I do the opposite operation. So instead of subtracting 60, I add 60. 120 plus 60 gets me 180. 15x is equal to 180. I now have to divide both sides by 15, which isolates the x. 180 divided by 15, I believe, is 12. And as usual, I just check in my handy-dandy calculator because I don't want an arithmetic mistake to mess up the answer to my question, and it is 12. So x equals 12. This guy's good to go. Here, we have no addition or subtraction, so we can go straight to dividing. We get x is equal to 4. Nope. This guy, very similar. No addition or subtraction. We go straight to dividing. X is equal to 12. He's good. Here, we add 4 to both sides. The x is already by itself, so we don't have to divide or multiply by anything. We get x is equal to 12. In this last question, we're going to add 12 to both sides, which gets us 12x is equal to 36. Now we have to isolate the x by dividing, and we're left with x is equal to 3. That is not 12. He is not the correct answer. So go through each of your answer choices, do a little bit of math to solve, and you'll quickly get to the correct answers. Problem number 3. Jada has a coin jar containing n nickels and d dimes worth a total of 365. The equation 0.05n plus 0.01d is equal to 365 is one way to represent the situation. Which equation is equivalent to the equation above? Okay. Well, when I see 0.05, I realize it's talking about the amount of $1, so it's like 5 cents, and this over here is 10 cents, which just helps me situate what my question is asking. So in this case, to get from 0.05 to 5, we had to multiply, or to go backwards, we're going to divide by 100, which gets us 0.05n, which means we divide this dude by 100, which gets us 0.01d, and we multiply this dude by 100, which gets us 3.65d. So, is this answer correct? Well, this term is wrong. So, nope. Now in this case, let's do it. To get from 0.5 to 0.5, we have to divide by 10, which means we have to divide each term by 10. So we get 0.5n, which is what we want. We get 0.1d, which is also what we want. But here we get 65.5, 36.5. Not what we want. So nope. Let's keep trying. Well, to get from 5 to 5/100ths, we divide by 100. This is 0.05n. Okay. We have to divide this term by 100, which gets us 0.1d. We multiply this term by 100, which gets us 3.65. This guy is good to go. Now, as we always do, we double check all of our answers because we sometimes make mistakes. In this case, we have 0.05d times 0.01n is equal to 365. To get from, they switch the d and the n here, and looking at this, we'd have to think, okay, so what times 0.05d is going to get us 0.01d? And that would be, I'm not sure off the top of my head. I would have to use a little bit of a calculator. But in this case, D is represented by 5 cents and N is represented by 1 cent. And however you cut it, nickels are 5 cents, dimes are 1 cent. So switching those variables leaves us with an equation that is not correct. So rather than doing all of those work, I will realize that the ratios between those two values are wrong and cross it out and go back to C, which was the answer I liked anyways. All right, if you have any questions, post them in the comments. But sometimes doing these questions about finding the most efficient manner and not necessarily doing all of the work for every single question. Problem number 4. Select all the equations that have the same solution as 2x minus 5 is equal to 15. So let's go ahead and solve. We add to both sides. We get 20. We divide by 2. We divide by 2. X is equal to 10. So that's what we're looking for. In this case, 2x is equal to 10, which means x is equal to 5. We cross them out. 2x is equal to 20, which gets us x is equal to 10. He is good to go. Now, in this case, there's 2 ways to do these types of questions. I'm going to get rid of this 2 by dividing, which gets me x minus 5 is equal to 15 divided by 2, which is 7.5. I add 5 to both sides. X is equal to 12.5, not equal to 10. Keep it moving. In this case, I'm going to add 20 to both sides. I get 2x is equal to 20. I notice it's the same as B. I work smart, not hard, and I realize that's the correct answer. Here, I'm going to add 10 to both sides, so I get 4x is equal to 40. I divide both sides by 4. X is equal to 10. He is good to go. Now here, x is on this side, but that's okay. So we are going to minus 5 from both sides, subtract 5, which gets us 10 is equal to negative 2x. We divide by negative 2, divide by negative 2, which gets us x is equal to negative 5. We do not like that because that is not 10, so that is not our correct answer. And we cross it out and move on to the next question. If you need to pause to review this as I go on, feel free to do it. Problem number 5. The number of hours spent in an airplane on a single flight is recorded on a dot plot. The mean is 5 hours, and the standard deviation is approximately 5.82 hours, which means usually it takes about 5 hours on a flight. But it is pretty normal to deviate about, I'm going to say about 6, because 5.82 is close to 6, about 6 hours above 5 hours and 6 hours below. Well, a little bit less than 6, because you can't have a negative flight. So a 5-hour flight would be normal, an 11-hour flight would be normal. A very short, close to 0-hour flight would be normal in this case because its standard deviation is about what's the range of normalness. The median is 4 hours, and the IQR is 3 hours. The value 26 is an outlier that should have not been included in the data. When the outlier is removed from the data set, what is the mean? Well, we're going to cross out this outlier, and we're going to have to recalculate the mean. So we have 2 flights that are 1. We have 2 flights that are 2 hours. We have 3 flights that are 3 hours. We have 3 flights that are 4 hours. We have 2 flights that are 5 hours. And we have 2 flights that are 6 hours. And looking at the data, honestly, I know these average out these, which average out these, which average out these, which is going to leave us with a mean of 3.5 hours. But if I calculate in my handy dandy calculator and say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, I divide this by 14. So 1 plus 1 is 2, plus 2 is 4, plus 2 is 6, plus 3 is 9, plus another 3 is 12, 15, 19, 23, 27, 32, 37, 43, 49, 49 divided by 14, which is going to give me 7 divided by 2, which gets me 3.5 hours. All right, so over here, I said my mean is going to be between 2 and 3, and we got our mean as 3.5 hours. What is the standard deviation? The standard deviation is definitely going to squish and become a lot smaller. We're not going to calculate this in this problem set, so if you have a question about how to do the standard deviation, I recommend you going back all the way to lesson 14 to review how to do that, because that's a long time and we don't have time for that in this video. What is the median? Well, the median, we're going to go ahead and we're going to realize all these numbers cross out as we get to the middle number. We're left with these 2 in the middle. The median is going to be the middle of those 2 values, which is going to get us 3.5. As for the IQR, we line up our numbers in order, which is nice. We already calculated that. We take our middle numbers. Those were 2 middle numbers. And then we're going to find the middle of these guys. So 1, 2. And the middle 2 numbers are going to be 2, which gets us the Q1 is equal to 2. And when we cross out, our Q3 is equal to 5. So our IQR is Q3 minus Q1, which is equal to 5 minus 2, which is equal to 3. And that's going to be our interquartile range. If you have any problems with these statistic questions, I recommend going back to my Unit 1 videos and looking over, because we go into that in much more depth over there. Problem number 6. A basketball coach purchases bananas for the players on his team. The table shows the price in dollars of P of n bananas. Which equation could represent the total price in dollars for n bananas? So 7 bananas cost $4.13, 8 bananas cost $4.72, 9 bananas cost $5.31, and 10 bananas cost $5.90. Which, doing some quick division, I realize a banana cost 59 cents. So does P equal 50.59 times N? Well, 59 cents times the number of bananas, this looks like it is correct. Is P going to be 5.90 minus 59 cents per banana? Well, 5.90 minus, if I brought 1 banana, let's think, 5.90 minus 0.59 N, that doesn't make sense, because that would give me the price of 9 bananas, not the price of 1 banana. So, nope. Is P equal to 5.90 divided by N? If I bought 1 banana, would price be 5.90 divided by 1? Nope, that would give me 10 bananas. Is P equal to N plus 0.59? So, would P equal to 1 plus 0.59? That would mean 1 banana costs $1.59, and we've already determined that 10 bananas cost, that 1 banana costs 59 cents. And the way I calculated this is if 10 bananas cost $5.90, that quickly tells me that 1 banana costs 59 cents. I could have also figured that out by figuring out the difference of cost between getting 7 bananas and 8 bananas, 8 bananas and 9 bananas. But I wanted to go quick here. So the correct answer in this case is A. And we're going to go on to problem number 7. Now, there's always multiple ways to solve a question. So if you find a different way, please let me know in the comment and I'll be happy to look at it. Problem 7. Kieran is collecting dimes and quarters in a jar. He's collected $10 so far. He has D dimes and Q quarters. The relationship between the jars of dimes, between the numbers of dimes and quarters and the amount of money in dollars is represented by the equation 0.01D plus 0.25Q is equal to 10. Select all the values that could be solutions to the equation. So in this case, we have a value for D and a value for Q. And it tells us the order for DQ, which is helpful because sometimes when it's X comma Y, we can always assume X comes first and Y comes second. But here, we're going to say D is equal to 100, Q is equal to 0. Not 10, it's going to be 0. And we're going to say, does this make our equation true? So 0.01 times 100 plus 0.25 times 0, is this going to get us 10? And we get 10 plus 0 is equal to 10. So this guy is good. For B, D is equal to 20, Q is equal to 50. So we get 0.01 times 20 plus 0.25 times 50. Is that equal to 10? So we move the decimal over once. That gets us 2. 25 times 50 cents is equal to, handy dandy calculator, 12.50. I know that these two are not equal to 10. This is not a good answer. So for C, D is equal to 50, Q is equal to 20. We're going to have 50 times 0.1 plus 0.25 times 20. Is this equal to 10? Well, this is going to give us $5 plus 0.25 times 20. And work smart, not hard. Use my handy dandy calculator is equal to 10. Yep, this guy is good to go. If D is equal to 0 and Q is equal to 100, well, 0.01 times 0 plus 0.25 times 100 is equal to 10. Well, this is going to get us $25. $25 is not equal to 10. Cross them out. In the last question, we have D is equal to 10, Q is equal to 36. We plug them in, 0.02 times D, which is 10, plus 0.25 times 36. Is that equal to 10? This is going to give me $1, and 0.25 times 36 is $9, is equal to 10. Yup, this is correct. All right, so go ahead, plug and chug each one. I personally always like expressing what is equal to what, so when I'm plugging and chugging, I know exactly what I'm doing. But if you're comfortable not doing that, go ahead and do it what's best for you. There are always multiple ways of solving the same questions. Problem number 8. There are a lot of problems in these questions, or a lot of questions in these problem sets. Here is a graph of the equation 3x minus 2y is equal to 12. Select all the coordinate pairs that represent a solution to the equation. I like the graphing ones because all I need to do is say 2, negative 3. He lives right there. He's on our line. We are good to go. 4, 0. He lives right there. He's good to go. 5, negative 1. He's over here. Not on our line. Not good to go. 0, negative 6. I go down. He is on our line. Good to go. 2, comma 3. Not on our line. Not good to go. And we're done. That's it. Now, we could plug in each of these points like we did for the last one, but I find looking at the graph is way easier, so we're going to skip that step. Problem number 9. Finally, our last question. Jada brought some sugar and strawberries to make strawberry jam. Sugar costs $1.80 per pound and strawberries cost $2.50 per pound. Jada spent a total of $19.40. Which point on the plan could represent the pounds of sugar and strawberries that Jada used to make jam? So, looking quickly at the graph, I see the bottom line is a sugar in pounds, and the top line is a strawberry in pounds. And this is how much it would cost if, for example, she brought no sugar and no strawberries, it would be $0. If she brought 6 pounds of sugar and 1 pound of strawberries, that would represent right there. So this doesn't give us the cost, but this line represents all the different data points where her cost would equal to 1940, which tells me that the only one that will be equal to 1940 is going to be the point that's on our line, which is point B. And if we look quickly, it means for sugar, she got 8 pounds. And for strawberries, I don't know how to spell strawberries, she got 2 pounds of strawberries. And it would be 2 times 250, which is $5, plus 180 times 8 should be 1940, which gets us $5 here, plus 180 times 8. I use my handy dandy calculator in order to make sure I'm calculating this correctly, which gets me 1440 is equal to 1940. And when I add this together, I get 1940 is equal to 1940. So this is correct. So B would be my correct point. Now, if you were not sure about what that line meant, you could identify each point the number of pounds of sugar and the number of pounds of strawberries and calculate how much it would be and see if it is equal to 1940. But because I know graphically this is what my graph means, I can easily say B is on the line that represents the relationship between strawberries and sugar that she can buy, dependent on it equaling 1940, and go ahead and say this is my correct answer. All right, as always, if you have any questions, put them in the comments below. If you like this video, please like and subscribe. Let me see here. Let's go. Like and subscribe down there, and I will see you in the next one.